Now we will learn the shortest job first scheduling algorithm. So this shortest job first scheduling algorithm that schedules the process according to their burst time. This is the main difference in between the first come first serve algorithm and shortest job first algorithm. In first come first serve algorithm, it checks the arrival time of all the processes and the process which arrives first in the ready queue that will get placed into the CPU. Whereas in the shortest job first, it checks the burst time, CPU burst time of all the processes. In the shortest job first, instead of checking the arrival time of the process, it check the CPU burst time or execution time or completion time which is required by that process to complete its job. So that are compared, and the process which required the shortest time or a short time to complete its job, that will get selected by the short term scheduler or by using the CPU scheduler. Okay, so the process with the lowest burst time or lowest processing time among the list of available processes which are present in the ready queue that are scheduled first. But it is very difficult to predict the burst time or processing time required for process. Because of this, it is very difficult to implement in the system. Means process start होने से पहले ही हम बता नहीं सकते कि how much time will be required for that process to complete its job. So because of that, implementation of this algorithm is difficult. Consider the processes P1, P2, P3, P4 given in the below table arrives for execution in the ready queue with arrival time 1, 2, 1, 4 respectively, and given the burst time for all processes are 3, 4, 2, 4 respectively. So find the completion time, turnaround time, waiting time, response time, average turnaround time, average waiting time, and throughput using shortest job first scheduling algorithm. And this word is very important here. Though we are using the shortest job first algorithm, we have to use the non-preemptive approach processes by using the tabular representation. So process number. So here many times in the exam, instead of using the variables P1, P2, P3, P4, the numbers are given 1, 2, 3, 4. So that are nothing but the process identification number which is given by an operating system to track that process or to identify that process, and this identification number is unique for each process. After that, in the next column, arrival time is given, that is at what time that processes are arrived in the ready queue. And in the third column, burst time is given, that is total execution time required by that process to complete its job. Which criteria we are using here? Here in the first come first serve algorithm, we have compared the arrival time of all the processes which are present in the ready queue, and here we are comparing the burst time of all the processes, that is total execution time of each process. And here we are using which mode? That is non-preemptive mode. So this is very important here. In the first come first serve algorithm, criteria is arrival time, and mode which was used, that was non-preemptive approach. See, this is the tabular representation. So now at first we will draw the Gantt chart by using this tabular representation. So the process of making the Gantt chart, it is different for all the scheduling algorithm. Afterwards we are using the same formula, but you should understand that how to draw the Gantt chart for each type of scheduling algorithm. Here there are 4 processes in a ready queue, and that processes are P1, P2, P3 and P4. So though there are in the tabular representation, though 4 processes are given, their arrival time is different. That is process here it is not given that it is that arrival time, it is not mentioned in terms of minutes, second, millisecond, microsecond. So you can assume anything here. So here you can assume that at 1 o'clock P1 and P3 it enters into the ready queue. At 2 o'clock process P2 enters into the ready queue, and at 4 o'clock process P4 it entered into the ready. So you can assume any time unit for this. So let us consider that here we will call that unit as time unit. Okay? So from this tabular representation we can see that we will always start from the zero time unit. Okay, so here you can observe that no process has arrived into the ready queue at zero time unit. Matlab, here we will draw the Gantt chart for 111 time unit. Means at first we will consider the first time unit, that is from 0 to 1. So here at 0 time unit, no process is arrived in the ready queue. So because of this, no process is selected by your CPU scheduler, as no process is present in the ready queue. So that time your CPU it is idle because it is doing nothing. It is not executing any of the process. So how we can represent it in the Gantt chart? So you can show it like this. That is, we will start from the zero time unit, and at zero time unit, no process is entered into the ready queue. So from zero time unit to one time unit, your CPU is idle. And here we are representing that CPU it is doing nothing for this one time unit. Okay, then after that we will check for the one time unit, means at 1 o'clock. So check out at 1 o'clock how many processes are entered in a ready. So here you can observe that process P1 it entered at 1 o'clock, and process P3 it is also entered at 1 o'clock into the ready queue. So now what we will do here, we will represent this table separately for the ready queue. Means for easy understanding, I am representing it separately. So what I will do here, now your CPU scheduler, what your CPU scheduler will do? So at first what we will do, we will represent C, process P1 it entered at one time unit, and process P3 it entered at one time unit in the ready queue. So I am representing the ready queue over here, and I am representing that ready queue like this, that is arrival time. This is for your understanding, okay? Arrival time, name of that process, and burst time. And I'm representing here ready queue. So at zero time unit, no process was there in the ready queue. But at one time unit, process P1 it will entered into the ready queue, and process P3 it will entered into the ready queue. So I will represent it like this. That is, arrival time for process P1 is 1, and the total time required for its execution is 3. Arrival time for process P3 is 1, means here I have changed this sequence. Now in the first column I am representing the arrival time, and in the second column I am representing the process. So process P3 at entered at 1 o'clock, and total execution time required for that process it is equal to 2. And draw the Gantt chart for this 0 to 1. So on x-axis we are representing time. Okay. So now two processes are there in the ready queue, P1 and P3. Now the criteria used by the shortage of first scheduling algorithm is the burst time. That is total execution time required to complete that process. So what your CPU scheduler algorithm will work, or how your shortage of first algorithm it will work. So what it will do, so it will compare the execution time required for the process P1 and P3. So here the execution time required for process P1 is 3 and process P3 is 2. Though both the processes are arrived at the same time at 1 o'clock only, but here we are not using first come first serve algorithm. Here we are using the shortage of first algorithm. So it will compare this burst time. So here you can observe that the total amount of time required to complete the process P3 is 2 and P1 is 3. So what your CPU scheduler algorithm will do? Here it will select the process P3, will select the process P3 from the ready queue, and it will assign the CPU to that process. But here you can observe that from 0 to 1 time unit तक आपका CPU idle था. So at 1 time unit, your process P3 it will enter into the run state. Okay, and total time unit required to complete its job is 2. So how we will represent it? Process P3 it will enter into the CPU, and after that, as this is a non-preemptive approach, your process P1 it cannot interrupt, or any other process if it entered into the ready queue, it cannot interrupt that process P3. So it will complete its execution, then only it will come out from the रन स्टेट, बिकॉज इट रिक्वायर टू टाइम यूनिट. तो 1 o'clock को अगर वो प्रोसेस ने एंटर किया है रन स्टेट में, तो इट विल एग्जीक्यूट फॉर 2 hours. तो 1 + 2 मीन्स 3. मीन्स 3 o'clock को that process P3 it will come out from the CPU. So here I will represent P like this. Okay. तो अभी आपको क्या करना है, मीन्स here you can observe that at 1 o'clock two process entered into the queue, that is P1 and P3. After that 1 और 3 में 2 o'clock है. So check out in the process table that at 2 o'clock any process is there which entered into the ready queue. So when process P3 it was executing, when it was utilizing the CPU time, that time at 2 time unit or at 2 o'clock, at 2 o'clock, process P2 it enters into the ready queue. When this process P3 was executing, that time process P2 it has entered into the ready queue. So what we will do now? We will select this process P2. Okay, so before that means here I am showing that this process P3 is completed because this is the non-preemptive approach. So it is completed its job and now it enters into the termination state. Now here after it is terminated, so here I can cut that process from the ready queue because it is already completed. It is no longer required CPU. So I can write that that process is completed. Now here at 2 o'clock process P2 entered into the ready queue. So what I will do, now here I will take out that process from this table and I will enter it into the ready queue. And I am entering it like this, that is arrival time for that process was 2, name of that process it is P2, and the total burst time is equal to 4. So like this you have to do the entry into the ready table. Now after that what you have to do, अभी प्रोसेस P4 it is entering in the ready queue at 4 o'clock, but अभी तक हम Gantt chart में 3 o'clock represent कर रहे हैं. So because of this process P2 it entered into the ready queue. Now what you have to do, only two processes are present in the ready queue. So your shortage of first scheduler, what it will do, it will compare the burst time of process P1 and P2. So next process will be process P1 because 3 it is less than 4. So burst time required to complete the process P1 is 3. So what your CPU scheduler will do, it will take out the process P1 from the ready queue and it will assign the CPU to that. So here I can represent after P3 I can represent process P1 here 6. 3 plus 3 that is 6. So we can represent it over here. So write down there 6. So now here, as this is the non-preemptive approach, your process P1 it will get executed completely and after that only the CPU is assigned to the another process. So here your process P1 is completed. So what we will do here? So process P1 is completed. So I can write here P1 is completed and now that process P1 it will no longer require the CPU. So you can remove that process. That process is already removed from the ready queue because of the non-preemptive approach that is completed. So only one process is present into the ready queue, that is process P2. So here you can observe that at 6 o'clock this process P1 is completed. So in between the execution of the process P1, that process P4 it is arrived in the ready queue at 4 o'clock. जब प्रोसेस P1 एग्जीक्यूट हो रही थी तभी at 4 o'clock को प्रोसेस P4 ने एंट्री लिया है रेडी क्यू में. So what we will do now, we will select this process P4 and here ready queue is assigned to that process P4. So what we will do, so ready queue is assigned to that process P4 and I am writing it like this, arrival time is 4, name of that process is 4 and here burst time is 4. So now again what we will do, only two processes are there because P1 and P3 का execution already complete हो गया है. So only two processes are there, P2 and P4. So shortage of first, this algorithm it compares the burst time of the process. But here you can observe that the burst time of process P2 and P4 is same. So now how your algorithm will work now? So both the processes are present in the ready queue, but now their burst time is also same. So in that case, your algorithm it will use the first come first serve approach. Yes. So at first it will select P2 and then P4. So it will assign the CPU to the P2. What will be the completion time for the process P2? 6 o'clock को उसने entry लिया है. So 6 plus 4 means it will come out from the CPU at 10 o'clock. Okay. So now once this process, as this is the non-preemptive approach, so this process P2 is completed its job. So it is no longer requires CPU. So only one process is there which is present in the ready queue, that is P4. तो अभी क्या करना है आपको, simply you have to, means your shortage of first, it will assign the CPU to the process P4. So process P4 it will get the CPU, it will execute its job, it will be the completion time now. So it is 10 plus 4 means 40. Okay, so it is 40. So all the processes are completed at 14 time units. So here I can cut that process from the ready queue. So it is completed. So your ready queue it is empty now. No processes are there in the ready queue. Means the execution of all the processes are completed by using the short term algorithm. So the drawing of Gantt chart is very important for all the scheduling algorithms. And after that all the formulas are same. So from this Gantt chart, now we will find out the completion time which is required for the execution of each process. So see, this is your Gantt chart, and after that, this is the table which was given. So what we will do now? We will find out the completion time at which process completes its execution. So now you can make the new entry in the table, that is completion time. So it is completing at 6 time units. Yes. जो right hand side का number है, that is representing the completion time. So here I can write that it is 6 time units. Then what is the completion time for the process P2? P2 का 10 time unit. Then P3 is 3 time unit, and P4 is 14 time, like this. Okay. So the next entry is turnaround time. So what is the turnaround time? It is the total time spent by the process into the primary memory. So primary memory में only दो states है आपका, ready state and the run state. So the total time spent by the process in the ready queue as well as in the run state, that is nothing but the turnaround time. So abhi all the processes are not entering at 0 time unit, that are entering at arrival time of all the processes are different. So how we can calculate the turnaround time? We can subtract the arrival time from the completion time, क्योंकि arrival time सबका different है और हमें क्या calculate करना है कि process how means at how many time units that particular process it was present in the primary memory. So here by using this formula we can find out the turnaround time. So it is completion time minus arrival time. So it is 5, 8, 2 and 10. Then next is waiting time. So waiting time का मतलब होता है कि waiting time is the total time spent by the process in the ready state, waiting for the CPU. Okay. So how to find out the waiting time? Turnaround time minus burst time. It is 3 minus 1 2. अभी Gantt chart से ही हम process P2 का waiting time calculate करते हैं. So it is means CPU is assigned to that process at 6 time unit, but it has entered in the ready queue at 2 time unit. So 6 minus 2, which is equal to 4, like this. Abhi P3. So P3 CPU is assigned to the process P3 at 1 time unit, and it has entered into the ready queue at 1 time unit. Means उसको उसका waiting time क्या हो गया यहाँ पे 0. 1 minus 1, that is 0. From the formula also you are getting all this. Then for process P4, तो P4 CPU is assigned to the process P4 at 10 time unit. जो लेफ्ट हैंड साइड का नंबर है वो राइट हैंड साइड का कंप्लीशन नंबर है, कंप्लीशन टाइम रिप्रेजेंट कर रहा है. एंड यहाँ पे हम वेटिंग टाइम कैलकुलेट कर रहे हैं लेफ्ट हैंड साइड को, दैट इज CPU इट इज असाइंड टू द प्रोसेस फॉर द फर्स्ट टाइम at 10 time unit. So 10 minus 4, it is equal to 6. Okay. After that, the next one is the response time. So response time, and this thing is very important. Response. So what is the response time? It is the time spent when the process is in the ready state and get CPU for the first time. Okay. So how we can calculate the response time? Similar to the waiting time. मतलब time at which the process gets the CPU for the first time minus arrival time, because this is the non-preemptive approach. नॉन प्रीएम्प्टिव में एक ही बार उसको सीपीयू मिल रहा है और वो कंप्लीट हो रहा है उसमें एग्जीक्यूशन. तो यहाँ पे हम हाउ वी कैन कैलकुलेट द रिस्पॉन्स टाइम हियर फ्रॉम द गैंट चार्ट, सेम लाइक सिमिलर लाइक द वेटिंग टाइम. So we will consider the left hand side number of the Gantt chart for each process, and we will subtract the arrival time from that. So it is same. Okay, so that will be 2, 4, 0, 6, like this. In preemptive approach, you will understand that difference in between the waiting time and the response time. Now, what is the next question? You have to find out the average turnaround time. Total of all the turnaround time of all the processes divided by number of processes. So it is 6.25. Okay. Then average waiting time. All the waiting time, addition of all the waiting times divided by total waiting time of all the processes divided by number of processes. So it is 3 time units.